This 4 hours workshop on the topic of data science. As it's a really vast topic, we're going to be covering up a part of that topic, which is a bit of analytics on a particular, you can say root cause analytics on a particular use case. Right? So it's going to be a super interesting workshop, and we're going to be learning one of the very important thing, which is like what is exactly data analytics and how do we do that. Right? So that's one of the uh, thing that we're going to be looking at, and we're going to be going through. Right. So let's get started. So welcome you all to the data science workshop. My name is Anshu Pandey, and this workshop is for you from Couses, which is the parent company that brings this particular workshop here. Who am I? What's my name? I hope my screen is also visible to all, right? Or you can see my screen as well. And so, yeah, who am I? So my name is Anshu Pandey, as I mentioned. And what I do is I work as a technical consultant, right? And that's what I do in general. And I'm a Microsoft certified trainer. I also work as a data scientist. I mean, I'm primarily a data scientist. I work as a Microsoft certified trainer. And so as part of that, I do deliver a lot of trainings to organizations. Right. I hope my audio is proper. My voice is low too. Isn't that the issue with everyone here? I think that's a challenge. Let me just cross check it with it. Okay. Am I now probably audible? Is this better?
Yes, sir.
Okay, thanks for the information. And okay. So, well, I'll recommend all of you to kind of keep your microphone on mute if possible until you need necessarily to ask a question, right? So please keep yourself to mute. In case you want to put a question, you can unmute yourself at any point of time. All right. So here we go. Well, so my name is Anshu Pandey. I work as a senior technical consultant for Tech Ventures. I am primarily a data scientist. I am a Microsoft certified trainer, and I'm also certified for a few other organizations like Wiley, AWS, and a few more. So from last 8 years, I've been working as a data scientist and data science associate and similar other roles. What I do now is I help enterprises to design their data science strategy and the architecture of the data science transformation and the AI transformation that they are planning on. So that's what I do, and that's a super interesting job. So now let's get started with the main topic of this particular workshop, which is we're going to talk about what exactly is data scientist. So what exactly is data science in general? So primarily, maybe many of you would have taken some courses, or maybe you would have, as you're having some interest in data science, you would have already gone through few examples, possibly videos, possibly some introductory sessions as well. So you may or may not be having a little understanding of the topic, what exactly is data science. So let's have a quick look at that. So when it comes to understanding data science specifically, it's a field of technology where we make use of structured data, where we make mostly use of structured data. We apply statistics and visualization on the top of structured data to perform analytics. Plus, it's a field which also leverages the power of deep learning, machine learning, and AI. So primarily, artificial intelligence is a field which deals with developing intelligent solutions. And so there are a lot of algorithms in AI which can be used to develop intelligent solutions. Few of those algorithms which use data to build intelligence are part of a subset called machine learning. So there are many algorithms in machine learning, right? And all the algorithms from AI which use data are part of ML. There's another subset of ML which what we call as deep learning, and that's where we have a set of algorithms which perform automated feature engineering. That means they select the features automatically in order to build a predictive model. So these are the three categories of algorithms which are used to develop predictive models. Data science is a field which leverages these fields like machine learning, deep learning, and AI on the top of data, primarily structured data. And data science is not only concerned with ML or deep learning and AI. It also is, it also include a very important field, a super important field, I would say, which is data analytics. And that is where we do is we sort of apply statistics, visualization on structured data. Of data in general, structured and unstructured. Structured data is like anything which is tabular data, like Excel sheets, CSV files, SQL database tables, are examples of structured data. Unstructured data, which is like images, videos, text, audio, these are all examples of unstructured data. So data science mostly, in data science we mostly deal with the type of data which is structured data. And so yeah, that's one of the important things, right? So I hope this makes a little sense about what exactly is data science in general, right? And so primarily it includes two different fields. In fact, we can say three different fields, which starts with data engineering, where we start collecting data. Second is analytics. Third is where we apply ML or DL. Right. So that's about it. That's a general overview idea. This workshop mainly not focuses on giving you the fundamental understanding. Like we could have spent around 1 hour on this single slide to understand and talk more about each and every terminology. This workshop is going to focus more on bringing you to a practical aspect of what kind of problems do we usually solve with data science, and how do we assess those problems, and how do we approach any standard analytics problem, you can say, in general. Right. So that's a focus of this workshop, and that's where I have very few slides which we are having discussion on currently, and those are also incorporated in the student notebook. So we are not going to go through any PPT after this, right? So yeah, that's where we have we having a little limited discussion on these terminologies, right? And so that's one of the idea about data science in general. Moving further, the question is like, which programming languages do we use in data science in general? The answer to that is there are two popular programming languages, which include Python programming and R programming. These are the two most popular programming languages you can say that are available today so far, and for Python and data science, right? You have Java and a lot of other programming languages for different other tasks, but yeah, these are the programming languages mainly used for data science specifically. So R is very popular for statistics and analytics, but it's more of academic language. That means it is very much limited to universities and research fields. Python is more industry-oriented language. R is less deployment friendly. That means if you have to develop a solution at the end of the day from the data science part, Python becomes more friendly to deployment and developing a solution. R becomes a little less friendly with that. When it comes to deep learning or specifically computer vision or natural language processing, Python becomes super powerful in that case compared to R. So that's a very idea about it. Next, let's go further. So we're going to be using Python in this particular two-day workshop. So I hope it is expected that you have a little idea of Python, fair idea of it. So we're not going to be learning Python in general in this course. We're just going to be using Python for analytics. That's one thing. Now, this is a super important topic of the whole workshop, I want to say, which is understanding the whole idea of more of enterprise level idea of how an enterprise consumes technology, specifically and data. So when you look at the, when we closely look at the journey of any enterprise with data, right? So how do they start and where do they end with data, right? So what are the stuff that they do with data, and what are the things that they explore and kind of applications that they develop, right? For any enterprise, you talk about banking, you talk about finance enterprise, or you talk entity, or you talk about supply chain management, healthcare, education, oil and gas, mining, any company you talk about, how their journey goes in when it comes to consuming data. So the very first is what is happening in the business, or what has happened in the business, right? So let us say that I am having a business. So if I'm on a few shop or out to know that which of the Domino's outlet is making more sales or how much sales it is making. I don't want to know that how many whether people are coming or buying products in evening or morning, or when morning are they buying big dishes. That means are they coming with family or they are coming standalone. When they are buying pizza from Domino, are they ordering via online channels like Swiggy, Zomato, or they ordering via off channel walking through? So I want to have very fair and clear idea of how my customers are engaging, how many sales I'm making across multiple outlets, of how my business is performing. So the main business, what is happening, or what has happened, how many sales I have made in the last 6 months, how much profit I have made in the last 2 years, and how my employees are performing. These are very fixed questions which business want to get answered to every now and then. This is the very first step, which is where they want to start consuming data, because data is only thing which can answer this question. As an e-commerce company, if I'm having an e-commerce business, I would want to know that part of the country products, or which category of products are being returned more, how much profit I have gained from electronics, apparels, let's say groceries, are using my smartphone or they are buying more for web applications, right? Where do I need to do optimization in general? Which products are usually sold more in month of August in last 5 years based on that I want to post discount on that product or maybe some other product possibly. So I want to know what has happened in the past as well. And this is where a business starts consuming data. This is where a business starts exploring opportunities to get the solution to this. And that's where what they want to do is they want to get a description of the data. So the business already captures each and every data point. So whenever we buy anything from e-commerce, they capture data of the product name, the time of the purchase, and the amount of the purchase, the delivery address, the location, everything. So they want to know a descriptive idea of how the sales are being done. And the answer to this question, so it's a little misaligned. Let me just the answer to this question, the business gets from a field called as data reporting or business intelligence, BI in general, or data reporting. So as a this fresh college student possibly, or maybe you are switching to data science or data analytics. This is one of the entry-level job that you can get in the business. You can get as a BI professional or a business intelligence expert, or possible a BI manager. You're already working with BI. And this level doesn't require any programming skill. There are very popular tools like Tableau BI, Power BI, ClickSense, ClickView. These are very super popular tools widely used in the market, which are more drag and drop interfaces, and these are used to develop dashboards. So if I show an example of what you accomplish out of this is, you might end up developing a BI dashboard enterprise, which they can use for analyzing. Let's see if I show you sales dashboard, right? So this is how a sales dashboard looks like. You see this dashboard simply shows me right. So let's say this particular dashboard simply shows me the sales for a particular organization. So this is for Cloud9 Info Systems, and let's see the dashboard here.
So this kind of dashboard you accomplish creating with the help of Power BI or Tableau BI, right? So this dashboard simply helps me see, I want to see the Asia Pacific report. So it is going to simply filter out all the graphs to Asia Pacific. So these are the sales I'm making in Asia, estimated revenue I'm making in Asia Pacific, February, April, June, July, August, September. Right? And this is possibly opportunity value by pipeline. And so I can look at the country, let's say India. Specifically, these are the possible estimation in the month of July. Actual versus target revenue, right? So actual revenue versus target revenue. These are different charts it shows, right? If I go next further, I can see different charts, sales performance. Let's say I want to see sales performance for Japan. So this is what it enables. So this enables the enterprise leader or the decision maker to understand that what is happening in the business, right? Or what has happened in the business. So far, how has been my performance in past few years or maybe few months, how my company is performing, how different outlets are performing, how well they are doing, how much revenue am I generating, how much profit am I making, what the trends available, right? And how this is heading to, where am I making losses, right? So this is what the business gets answered to from the very first step where they enter into the world of data, or the very first step they take when they start their journey with the help of data. And this has to be first step for any enterprise. Some enterprises overlook this and maybe they kind of try to sort of shift on the top of this, but and later they have to come back. Now over here, this is the very first step business should go in. This is a step where after implementation of such dashboards, the business identifies what data to collect. So just keep on capturing data and they don't use that data. This is the step that they start using it and they identify the issues with the quality of data they are capturing, and what other data points that they are they would not capture. And then they get different questions, right? So this dashboards, the very first step, help the business to ask question. So let's say if, as a manager, if I see that my profit has been going down from last 6 months, why is it down? Customers are not coming back to the portal. Let's say I'm owner of a xyz.com e-commerce chain website. So only customers come for the first time their platform. So I want to know that if my sales are going down, I want to know that why this happened, why my sales are going down, why it happened in the past, is why it happened in the past. What this problem is static. Let's say in 2020 I might have issue with why my sales went down. In next year I might have issue as that why my customers are returning the products, or why are not they buying apples, why are not they why aren't they spending much on groceries, right? So why it happened in past. This field is what we solve with something called exploratory analytics, and we also call it as data analytics. It specifically specifically relates to the field of answering the question why it happened in past, why customers left the bank, why people are not buying Airtel SIM cards, why possibly machines are not manufacturing good quality products, right? Why machines are getting damaged, why sales are going down, why profit margin is decreasing, why customers are returning the product, right? Why the supply chain management or delivery is being delayed, right? Why are we getting a lot of complaints from customers? Why we are not able to sell in the central part of India, but we are able to sell in western part of India? All these questions of why it happened in past, those questions are answered in data analytics. The first two questions relates with mostly past data, and that's bring statistics and visualization to help answering these questions. This third stage where the business has to switch sequentially, and after this stage they reach to this stage, they identify that I'm making low sales. So I would want to know in future, in next 2 months, how much sales will I be able to make? Based on that, I would want to revive my policy of my business and improve the business. So the next question the business is going to have is what will happen tomorrow? This is what we call as predictive analytics. right? And this is where we consume machine learning, part of AI, right? This is where data science starts using machine learning. Mostly the part of machine learning we use is supervised machine learning. The tools that we use is Python R. Well, in this case, we use Python R and big data as well. Here we use mostly Python and R programming. We build models which can be used to do predictions. This is the third stage. A lot of business would want to, or they try to switch directly to the third stage, which is where they make mistakes because if they have not picked up the right journey, they get into the situation of not having qualitative data or not solving the right problem. The fourth stage where a business would want to consume, and very less of the businesses are on this stage at the moment. Only the big giants like Facebook, Amazon, Google are on this level. How can we make it happen? They use recommendation engines and stuff like that to predict, or maybe to use ML to make customers buy product, right? So how can we make it happen? How can we make the sales go high? Prescriptions, like the way doctor gives prescriptions, that this is the medicine you should take to get well soon, right? Similarly, a machine learning algorithm can give prescription that this is the advertisement you should pick up, or possibly these are the steps you should do, or these are the customers you should sell so as to get more sales out of it. So we call it as prescriptive analytics, right? That's the main name. And we consume here unsupervised machine learning algorithms. And the technologies used are Python, R, and big data. Right, so that's about it. That's about the journey of an enterprise with data, and specifically we call it as more of, you can say, specifically we call it as data science journey as well. Right, so you can also call it like more of a data science journey. Right. So I hope this makes sense, everyone. Any question that you have right here? Because now we're going to shift to the practical part, and that's where we're going to be actually working with one of the use case on this level to answer this question, why it happened in past. Any question? Are we all good so far? Right. So considering that we all are good, we'll go ahead. We'll move forward, right? So we'll take a step forward. Okay. So let's go further. And now we're gonna be working with a project, which is actually from this particular part. You can call it as so. This all four are part of data science, right? And we're gonna be starting with the second stage, which is like why it happened in the past, right? Why something happened. We call it as exploratory analytics, or in general data analysis. We also call it EDA, exploratory data analytics. Sometimes we call it root cause analytics, RCA as well. The tool that we'll be using here is Python, right? So that's the tool that I'm going to be using up. So our project is to work with and answer the question in a factory. So we have data of a factory, right? A manufacturing factory. And we are expected to answer the question, why machines are damaged in the factory. So we have the data of a factory, and there are machines in a factory. So we have data of around 1,000 machines of a factory. The data collected includes specific properties of the machine, like the lifetime of the machine, so how many months it's been the machine is in use. When the data was recorded, what was the condition of machine, whether it was damaged or it was not damaged. The pressure on which the machine was operating, the moisture on which machine was operating, the temperature on which machine was operating, the team which was handling the machine, was it team A, team B, or team C? The provider, the manufacturer, or the seller of the machine, who was the vendor who provided that machine. These are 7 attributes, or the information columns, you can say, and we are expected to sort of perform exploratory data analytics on this to be able to identify why it happened in the past, right? Why machines got damaged. So let me show you a structure of data so that we can understand, what data are we dealing with, and what kind of problem are we going to solve. So let me first load data. With that, I'm going to be using few packages like import pandas, import numpy snp, right? So let me. So I'm going to just copy this URL. If you want to have this data, I'm going to also share the link of this data in the chat. Right, this is the URL, and we can just directly pass the URL here. So I'm going to say we can simply say URL. And URL. Finally, we can say that here, see the data. So I can say here. This is the data that we have, right? So what do we have as part of our data? Yeah, it's there already. The link has been shared essentially in the chat. You can directly pass the link in the pd.read CSV. If you get a file, you can also then convert or download that from the data frame as a CSV or Excel file. You can also save as by going to that link, opening that link in the browser, right click on the web page and save as a CSV file as well. Oh, okay, the file, the Jupyter notebook. Sure, at the end of the session, I can share that because right now I don't have any code going further. I'm going to be writing the code in front of you. All right, so at the end of the session, I can share this file. Okay, so here we go, everyone. Let's understand the data, right? So this is the data that we have. We have the data of around 1,000 machines. You can see that we have total 1,000 rows and 7 columns, right? So these are the data we have. 1,000 rows, 7 columns, right? And we have, as part of our data, we have data of 1,000 machines. For each machine, we have lifetime. What is lifetime? As we can see, that lifetime is lifetime of the machine in months, right? So how many months it's been? So this machine is 56 months older. This machine is 81 months older. This machine is 60 months older, 86 months older, 34 months older, 88 months older, 88 months older, 22 months older. Like that. And second is we have broken. Broken shows whether the machine was damaged or not when this data was recorded. 0 means yes, no, this machine was not damaged. It was not broken. 1 means yes, this machine was damaged. 0 means